All right, so we're going to move on to 1.4. And 1.4 covers transformations of functions. And you learned that before in Math 3 if you took it here at Piedmont Hills. And this is just a review for most of you, but if it's new, you're going to have to pay extra close attention. All right. So f of x is your original function, or sometimes they call it the parent function, and g of x is the new and transform function. Okay, so in your notes, you're going to have name, under one column, appearance, meaning, okay, and then the coordinate rule. Okay, this last column is the coordinate rule. So let's start with the most easiest one, I think, which is a vertical translation. So if you have g of x, which is your new function, and you take your original function and you add k, well, this means it shifts the graph up by k units. What graph? Your original function up by k units. And what's the coordinate rule? Well, if you shift it up, right, you basically, for your coordinate rule, you take your original, you keep your x value, and you take your y value and you add by whatever that k is. Okay, so this last column is the coordinate rule. All right, what if you have g of x is equal to f of x, minus k, right? This means I'm shifting the graph of f of x k units down. Again, x comma y would just be, I keep my x value, but I take my y value and I subtract k. All right, so vertical translation, fairly straightforward. I think most students understand what this last number does. It shifts the graph up and down, hence the term vertical translation. All right, now horizontal translation is a little bit trickier in appearance. And what I mean by that is if you have x plus h, something like this, you would think you shift the graph h units to the right because it's positive, right? But actually what I tell my students is, it's technically you shift it h units to the left, and I can rewrite positive as minus minus, right? And the number after the minus sign is negative h. So actually, when you see f of x plus h, you shift the graph of f h units to the left. And if I shift the h units to the left, it impacts my x values. It's x minus h, and of course you keep the y. All right. And likewise, right, if you see, f of x minus h, this means you shift it h units to the right, right? The number after the minus sign is actually a positive h. So x comma y becomes x plus h, right? And of course you keep the y value because you are only translating the graph horizontally. All right, so moving on to reflection of the x-axis. And this one is fairly intuitive. I think you guys have seen this before, right? You have a negative in front, right? The negative, all it does is reflect. And so for meaning, I guess I'm just going to leave this column blank. And well, what would the actual coordinate rule be if you reflect something across the x-axis? So let me just, maybe draw a diagram here in the meaning. If I have, 2 comma 1, right? And I ask you to reflect it across the x-axis. Well, the x-axis would be right here, right? This would be 2 comma negative 1. And so if you take a look, right, x comma y, what happened to x comma y? The x value stays the same, right? But the y value became negative. So, that's something you could always draw out if you forget. It's like, what was the reflection x-axis rule? Was it x negative xy or x negative y? So you can see here, right, it's xy becomes x negative y. All right, so reflection in the y-axis, g of x is equal to f of negative x. The negative is on the inside. And again, for the meaning, I will just maybe draw a grid here. Let's use that 2 comma 1 again. Well, how do I reflect 2 comma 1 across the y-axis? It basically becomes negative 2 comma 1, right? And so you can take a look what actually happens here. Your x comma y, the x value becomes negative, right? And then you keep your y value, all right? So that's if you have reflection on the y-axis, you see a negative on the inside of the function. Okay, number 1 through 4 are, translations and reflections. And they don't actually change the size of your graph, right? But once we get to 5 and 6, horizontal, vertical, stretch, and shrinks, you will definitely have the size of the graph being changed. Okay, so how do I know it's a vertical stretch? And it's going to say vertical stretch often by a factor of A, okay, if the absolute value of A is greater than 1. And what does it look like? It looks like this. G of x, let me erase if I can. G of x is equal to A f of x. That's what it looks like. All right, in terms of meaning, right, what does it mean to vertically stretch something by a factor of A? It means you pull away from the x-axis, okay? You pull away from the x-axis. And so if I could draw a picture, right, here's my graph of a parabola. I'm pulling this graph away from the x-axis. You can see the arrows. Hopefully you can see that. All right, so in terms of the coordinate rule, I basically keep my x by take my y value and multiply by a. So a times y, okay? That's what a vertical stretch is. It basically makes your graph narrower than the original graph. All right, what about a vertical compression or shrink? Either one of these words are synonymous. I mean, both of these words are synonymous. You could use the word shrink or compression. It's also going to be by a factor of a, but this is if the absolute value of a is between 0 and 1. Okay, and what does it mean when you say, do a vertical shrink or compression by a factor of a? It basically takes my graph right here. Maybe I'll have a little more space here. Here's my parabola, right? And it's gonna pull towards the x-axis, okay? So it pulls toward the x-axis. That's what a vertical compression or shrink is gonna look like. So basically it's gonna look something like this, right? It's going to flatten it, whereas this one is gonna be a little bit narrower. I don't think you can see all that dash mark there, but this graph right here is going to be wider than the original graph. This dash line right here, if you're pulling away, it's going to be narrower, okay? Coordinate rule is you keep your x, you take your y value, multiply by 8. All right. Very last one we have is a horizontal, or very last transformation we have is a horizontal stretch or horizontal shrink. All right, so this is the one where it's a little bit tricky, okay? So let me give you the appearance. The appearance looks something like this. G of x is equal to f of bx. Okay, so if you have something with inside your function, we'll call it b, it's either going to be a horizontal stretch or a shrink factor. Okay, so it's going to be horizontal stretch by a factor of 1 over b. Okay, so this is where it's a little bit tricky. If the absolute value of b is between 0 and 1. And what does that mean? What does that mean? So let me see, maybe if I could draw it over here. Let me take my parabola here. So if I said, hey, you have a horizontal stretch by a factor of b, it means I'm going to pull it away from the x-axis, okay? Or sorry, away from the y-axis. And so it would look something like this, right? If you pull it away from the y-axis. Pull away from the y-axis. Okay, horizontal stretch by a factor of 1 over b if the absolute value of b is between 0 and 1. All right, what does this actual coordinate rule look like? X comma y, right, is going to be x over b, and then over here you keep your y value. Basically, you take your x value, divide by whatever b is, all right? Okay, the very last one is a horizontal shrink or compression by a factor of also 1 over b, okay? But if the absolute value of b is greater than 1. And what is a horizontal shrink or compression? If I take my parabola, if you think about horizontally, right, I'm going to pull towards the y-axis. And of course, this graph will look something like this if you pull towards the y-axis. Pull towards the y-axis. All right, so you can see, right, that this picture right here, a horizontal shrink compression is the same thing as a vertical stretch, as just like a vertical shrink or compression, right, is the same thing as a horizontal stretch. So those are synonymous. That's an FYI, right? Okay, so what happens, right? Right now I did 1 through 6 with you, right? What happens if you have all 6 transformations, right? 1 through 6 are individual transformations. What happens if you have all 6? Well, the general form is going to look something like this. I'm going to have an A over here, and we'll call it F, bracket, B, X minus H, close the bracket, plus or minus K. All right, so every value, right, in here represents something, right? The A represents it being changed, the size of the graph being changed vertically. The B represents the size of the graph being changed horizontally. Not only that, right, the sign of A and B determine whether you have reflections over the X and Y axis. H, of course, shifts the graph left and right. K shifts the graph up and down, depending on what the sign is. Okay, so there's actually an order of transformations, meaning when you're given 2 operations, right, let's say you have a translation and a reflection, like which one do you do first? Obviously, okay, I don't know if it's that obvious, but you want to do all your stretches, okay, stretches and shrinks and reflections first. And the reason why is because you have to follow your order of operations, right? These guys right here, you need to multiply and divide, right? And then you do a translation. Why do we do translations last? Because these guys right here, you add and subtract, okay? And so hopefully that makes sense, why you do stretches and shrinks first, and reflections, and then translations, because it follows the order of operations. Okay, so there will be some examples in your notes that I basically do all of the transformations